So here we're going to talk about how we think about analyzing the data based on the type of variable that we have, categorical versus numerical. And in this, we're also going to tie in the idea of population versus sample. So we're going to get some new notation here, as well as some more definitions. So let's say we have categorical data. So if we have something that's like yes, no answer, something in words or images, then what we're going to be interested in is calculating the proportion. So proportion is another word for like a fraction, having some numerator out of denominator, and typically we end up expressing this as a percentage. So if you think about like a yes-no question, it's the idea of being interested in what was the proportion of yeses, or equivalently, what was the percentage of yeses. If we're looking at numerical data, then we are often interested in the mean. Or if you haven't heard of the word mean before, it's the same idea as average. So if I collected the heights of SPSCC students, I could be interested in the average height. So taking all of those values, add them up with each other, and divide by how many there are. Now, when we've kind of talked about these ideas, we talked about in that first video of how it's important to know where our data came from. Is it coming from a population or is it coming from a sample? And because of that importance, we're going to be seeing a lot in this class, kind of two forms of notation that really represent the same thing, but we change the notation based on if it's a population value or a sample value. So when we calculate something from a population, it's called a parameter. So that's why up above here at the top of the column, it says population parameter. That's tying to something that was calculated from a population. So if we're calculating a proportion that's coming from a population, our notation is just the letter P. If we're working with numerical data, and specifically numerical population data, and we take an average, then what we use is this symbol right here. It's like U with a little tail at the beginning. This symbol here, we say mu, M-E-W. It's a Greek letter, but it represents an average coming from a population. If we're working with sample data, then we call it a sample statistic. So something calculated from a sample, we always call that a statistic. If you're worried about mixing up parameter and statistic, the way I most often remember it is that they start with the same letter. Parameter, population, statistic, sample. So BNP, SNS. So if we're working with sample data, and specifically, let's say it was categorical data, so we're calculating a proportion, then the symbol we use is P with a hat on top, a little caret top there. How we would read that is P hat. So P hat. If we're working with numerical data and we calculate a sample statistic, then we represent that with X with a bar on top, and we call that X bar. So what we're seeing here is notation for proportions, notation for means. If it's a population proportion, we use P. If it's a sample proportion, we use P hat. If we're working with numerical data, if it's a population mean, we use that symbol mu. If it's a sample mean, then we use X bar. So the idea being that if I was talking about some proportion of people that said yes to something, it doesn't really matter what, and I said P equals 82%. That notation right there tells me a lot. I know it's a proportion. I can see it's a percentage based on the notation. But if I say P equals 82%, what's also implied there is that, oh, they had population data. Julia collected all of the data, calculated this proportion, and got 82%. So in with it comes that idea, of very difficult to obtain data and a very accurate number. Whereas if I just put a little hat on top of P, so P hat equals 82%, then what that notation conveys is, okay, Julia took a sample of the population that she's interested in and got this proportion of 82%. We don't know how she collected that data. We don't know what sample size she used, but we can assume there's going to be a little bit of error with that number. Depending on how well she collected that sample, maybe that 82% is really strong. So again, that idea that with a sample, it's easier to obtain, but has some error with it. So we want to be careful with this notation. What I even recommend doing for this class, because this will happen a lot when we calculate things, we'll have the population notation and the sample notation. What can be helpful is to have a piece of paper or a document on your computer that is just all about collecting notation. So having it set up like this so that you have proportion and then population versus sample, mean, population versus sample, and just kind of getting that all organized together. All right, so let's take these ideas and apply it. So let's look at this example. We have researchers are interested in the percentage of people in a city that support a new recycling law. Draw and label a picture to represent the population, the sample, the parameter, and the statistic. So first thing we need to think about is this going to be categorical or numerical data? So if we think about that we're interested in the percentage of people in a city that support a new recycling law, let's think about how we would collect this data. How would I get information on whether or not people support a new recycling law? Well, that could look like mailing something to everyone and asking them, do you support this new recycling law? So maybe that's what I would have asked on my survey. Do you support the new recycling law? The idea being that this is a yes or no answer. So what I would have is this list of yes or no answers coming from people in the city. And with that, my data is categorical. So sometimes just put yourself in the shoes of the researcher and it's like, how are you collecting this data? What would the data look like once you collected it? So since this is categorical, that means we're interested in the proportion. If we have categorical data, we can't take the average of it. Like these kind of ideas don't work across, is what I'm trying to say. If we have all these yes or no answers, I can't take the average of, I can't add them up and divide by how many there are. We have to have numerical data to take the average. So just know that categorical matches up with proportion, numerical mean. All right, so let's draw our picture. Population is big. So I'm going to draw this big rectangle to represent the population. And if I'm thinking about my population data, like I was saying, I was thinking of mailing everyone in this city. So my population would be everyone in the city. Or just to kind of, we talked about how population links to this word all. So let's say all people in this city. Now the sample is going to be a portion of this, so I'm just going to draw a circle that's inside of that rectangle, and that would be our sample. And this would just be some people in this city. So there's my population and sample. Population would be interviewing absolutely everyone in the city. Sample would be just talking to some people in the city. So the parameter. So let's talk about parameter and statistic. The parameter links to population. So we would have to be looking at our population data in order to analyze the parameter. So It's categorical data, so we're dealing with proportions. That means our parameter is going to be P. So what P would represent here, it's the proportion of, and since it's the population, all people in the city. All people in the city that support the new recycling law. So, parameter would be population proportion, and it's this proportion, or percentage and proportion are interchangeable, so really this is a percentage of people who said yes. Statistic is going to come from the sample. And with that, since it's a sample proportion, we would use our symbol p hat, and this would just be the proportion of some people in the city. You'll have some sample size that they choose. We could say 50 people, 100 people. It depends on what they decide to do. Of some people in the city that support the new law. So what you can see here is, in terms of definitions, P and P hat are very similar. The difference is for P, we're analyzing all people in the city. P hat is just some people. So it's that difference of population versus sample. Let's look at one more example here. So researchers are interested on the average days of shelf life for an apple at Trader Joe's in Olympia. Draw and label a picture to represent population, sample, parameter, and statistic. So if we're the researchers and we want to figure out the shelf life, then what we'd be doing is tracking apples and seeing how long they last at Trader Joe's. So what we would be writing down is number of days. So if we're writing down the number of days on our paper, then that means our data is numerical. And a hint would be too that they're interested in the average of those values, kind of like up above with that example with the recycling law. They were interested in the percentage. Percentage is going to link with proportion. Average is going to link to mean. So our data is numerical, which means that we're interested in the mean. So in terms of a picture, I'm going to draw pretty much the same thing as I did up above there. I'm going to do a big rectangle. And it doesn't have to be a rectangle, it could be any big shape. Basically, population should be big, sample should be small and within the population. So, population. This would be analyzing all apples. So, all apples at Trader Joe's in Olympia. So, if we collected the shelf life for all of those apples at Trader Joe's in Olympia, then we would have population data. Our sample, which is a portion of our population, would be some apples at Trader Joe's in Olympia. All right, population and sample, all of the apples versus some of the apples. So now let's look at our parameter and statistic. So parameter is coming from our population. So we'd analyze our population data. And since this is numerical, we would be taking a population mean. So for that, we use our symbol mu. So mu would represent the average shelf life of all apples at Trader Joe's in Olympia. Our statistic is going to come from a sample. So that sample that we take, we can get a statistic. Since we're looking at the sample average, we would be taking X bar would be our symbol. So X bar is equal to the average or mean. Average and mean are interchangeable with each other. Shelf life of some apples at Trader Joe's in Olympia. All right, so those ideas of population and sample coming through here, along with this new notation for population proportion versus sample proportion and population mean versus sample mean.